Hey, Mathematical Padawans, this is Mrs. Bird. I am going through the project presented in Unit 3, specifically all the questions that are presented in Lesson 12. So we're going to jump right into it. Some background information is Digit and Polly are helping out with a wedding that's happening here at the castle. They have set up the courtyard, including where the bride and the groom will be walking down the aisle. So they want to be looking at some transformations to rearrange the seating items. So we're going to be using our own knowledge about transformations as it applies to functions to help them rearrange things. So that should be making sense for what you know about transformations. Transformations in a word is moving a graph or a function. So we can move a graph or a function in a couple of different ways. One of which is called the translation, which is what question number 1 is all about. Now, before I jump directly into that question, let me just show you a diagram that I think really captures all of the different types of transformations, or in other words, all of the different ways that we can change or move a shape or a graph. The first thing is we can do what's called the translation. That's what question 1 is about. And in this example, you can see the translation, or in this case, the triangle being really physically moved. So it's being translated. I can see that coordinate point as being moved in some diagonal way. And if I copied that exact same diagonal, the length, the angle, everything, I can see the exact same thing happening here. So we're moving it in a very specific manner such that the shape does not change. I have the exact same triangles here. Now we can have a reflection. Other students might think of this as mirroring, where I can imagine a mirror right in the middle of these two shapes, and I get this mirrored image. So this could be my original graph. I call it my OG. And then I get this mirrored image on the other side. So here I can see that mirror being a vertical mirror, but sometimes it can be a horizontal mirror as well. So we can do what's called a horizontal or a vertical reflection. Another type of transformation is called a dilation. So a dilation is actually where we're changing the size. So here I can see if I'm given a smaller triangle, I can, that was a good triangle. But I can dilate, or in other words, enlarge that by some degree, or in that word, it would be called a scale. So sometimes I want things to be 2 times as big, or maybe I want it to be smaller and I would scale it by maybe a half, for example. But a dilation is where we're changing the size of, in this case, a shape or sometimes a graph. And then lastly, the last kind that we can do is a rotation. I grew up playing a lot of basketball, so I like to think of this as a pivot. So if I have a stationary point right here, that would be my pivot foot. I can see how maybe this got rotated around that pivot, and I can see how it got rotated around to be down here. So those are all the different types of ways that we can move or transform a graph. So if we wanted to go back to this first question, it's talking only about that translation. So it's talking only about this shape moving right here. So what best describes that translation? It keeps its position but changes its orientation. It cannot change its orientation. The only way to change its orientation would be to rotate it, to like spin it around, or to reflect it in some way. So not only does it have to keep its shape and size, but it has to be, but keeps its position. Well, the whole point of the translation is to move. So I can't keep a position. I can't keep that location. It keeps its shape and size, but changes in orientation. Nope. So it has to keep its shape and size, but it keeps shape, size, but moved position. Duh, I missed it. It's this one. Come on, bird. But changes position. I read that as keeps position. We are indeed changing the position or changing the location, which lines up with the translation and the idea of moving. So sorry about that if I misread that question. Just an example to keep you on your toes, to always read the directions and questions carefully. Okay, let's look at number 2. Now this is starting to take all of those transformations and apply them into some sort of mathematical rule. Now, all of these ways that we can transform a graph, whether it's moving left, right, up, down, or a dilation, we can always represent them with parameters. So these parameters are being represented by multiplying by 1/3 here, or a different parameter would be subtracting 10. A different parameter would be that -2. See how that -2 is kind of inside of the function, whereas that -10 is on the outside? That's indicating that these are different parameters. So first thing that I want to go over is, what do each of those parameters mean? It's coming from a general form. F of x can be mapped, or it can be changed in some way, moved around by the parameter a times the original function of 1/b x minus h plus k. So first I want to do is just identify what each of these parameters are. This 1/3, I can see that being a parameter of a, because it's a multiplier out in front. This -10, I can identify that to be the parameter of k, because it's outside of that function. So I'm going to try and color code all of these. This 2, now you'd maybe wanted to include that negative here, but if you see here, it's an x minus the h value. So here, that h value is just this 2. So that 2, I'm going to write that out just so that we don't forget it. The h value is a +2, which does represent that h. And I'm seeing something else here. I'm seeing a multiplier right here. That is a multiplier of a value of 1, of a -1. So that's also an a. So this has 2 different parameters in it. And then I see another negative right here, which is an a value. And lastly, we have the infamous b value. Kind of running out of colors. Brown. So that's that 1/2. So in this case, I'm going to throw this out here. B is a -2. I can see that 1/. So I see that 1/, and then the b value is down here with the negative. So that's a -2. Okay, we've identified what each of these parameters are with a number. A is 1/3, k is -10, but we also need to know what each of these do. So you might be recalling that the a is a vertical, so it's going to stretch, go up and down, vertical dilation. So this is the thing that makes things really tall or really short. The b value is a horizontal dilation. So it's going to make things really skinny or really fat. H is a, nope, that was wrong. I wrote the wrong word. It is a horizontal translation. Translation, I'll write the entire word. Horizontal translation. So that's going to move things either to the left or to the right. The k value, that is your vertical translation, which can move things up or down. So remember, a translation has to keep the exact same shape. It's just moving the graph. So what we want to do in question 2 is identify which of these has a reflection over the x or the y axis. So I could dilate either up or down, but anytime A is a negative, that is going to be a flip upside down. In other words, it's going to be a reflection over the x-axis. Got to go upside down over the monkey bar. Horizontal dilation can also, if B is a negative, that's going to be a y-axis reflection. So all of that to say, we are looking for either the A to be a negative or a B to be a negative to find the final solutions here. So A is a positive, no reflection going on. A is still a positive, there's a super-secret run right here, it's a positive, no reflection. This guy is a reflection, it's got a negative A value, and it has a translation to the right too, but that's not what the question was asking. This guy is also a negative A value, which would make the graph go upside down, reflecting it over the x-axis. And then lastly, this guy, since it's a negative, my B is a negative, I would be flipping it over the y-axis. So that's the mirrored image right there. So that, my friends, is question 2. Okay, and I'm back with question 3. So question 3 is again about transformations and dealing with these different parameters. So A, we got that B parameter, H, and then K. If you need another review on what those parameters are, I just talked about them in question 2, so just back up the video. So here we are looking at which of those, out of all of those transformation parameters, A, B, H, and K, which one has a vertical transformation? So that's going to be parameter A, because if you remember A, that is a vertical, if I can spell it, forgot my C, vertical dilation. So that's going to make things appear to be really tall or really short, but it is a vertical dilation. And then we have K, which is a vertical translation. Forgot that word for a second. So that's what's going to be picking up the entire graph and moving the entire graph either up or down. So out of these, I'm just looking for which one of those has the A or the K parameter. So this would be fine because this is a vertical dilation, or sometimes it's referred to as a vertical stretch times 3. This is because this is a K value, so this is moving up 8. This guy is not. This 8 right here is actually your H, so that would actually be moving things to the right 8. That is not a vertical. And then here I can see that B value of 3. Remember, it's 1 over whatever that number of B is. So it's 1 over that number 3. So that's going to be a horizontal dilation. So this is going to appear to be like 3 times fatter, but it's still not a vertical transformation. So that is question number 3. Let's have a look at question 4 here. Digit is good at transforming most functions. However, she's having trouble understanding how to perform a phase shift or a periodic on a periodic function. Okay, so what is a periodic function? It is something that happens periodically, which could be an example of your sine function. So if you remember your sine function, it looks like this, where wave, down, up. That is one full period of the wave, or one full phase. I prefer the name of phase because I can kind of see like that up and then down. So sine functions, cosine functions, they're always going to be periodic because they graph things on a certain interval. Meanings like if I continued, I would see another phase, but it would be the exact same thing. So it's repeating itself over a certain interval or a certain period. Okay, so just to review what that was talking about, a periodic function, sine, cosine functions. So now we're trying to identify a phase shift. A phase shift is where I'm taking this entire phase or this entire up down and I'm shifting it in some way. So maybe it's a transformation. Maybe it's a horizontal transformation, and then now I would have the exact same function moved left and right. So what she's wanting to do, or it seems to me that Digit is getting confused on the vocabulary here. She's comfortable with the vocabulary of transformations, translation, dilation, reflection. But now she just wants to apply that understanding as a phase shift. We're just using the word a phase because we're taking this phase, also known as a period, and then shifting it left or right. So mathematically, or I would say in a function, I can represent that to be y is equal to sine of, maybe I shift things to the right pi units, for example. That would be no different than, say, a cubic function being shifted pi units. It's still the exact same thing, but now we're just using different vocabulary to talk about the entire shape of the graph being one phase. So that is lesson 12. Hopefully that clarifies some things for you. And as always, please reach out to me if I can help.